Hi there! For this video, we'll be talking about some basics on polynomials, such as terms like variables, constants, coefficients, algebraic term, algebraic expression, as well as what polynomials are and what it's not. So let us start with variables. So variables are symbols that represents a unknown value. So that's the keyword, unknown value. So we can represent variables in like x, y, or even Greek letters such as alpha and beta. So variables are not necessarily just the alphabet letters. It can also be Greek letters. But the key thing is that these values are unknown. So for this one, x can be equal to 1, 2, 3, and such. So it can be any value. On the other hand, we also have what we call the constants. So constants are, on the other hand, are variables with a fixed value. So for instance, we have c is approximately 3 times 10 raised to 8. You can even put a unit of meters per second. So if you don't know what this is simply the constant for the speed of light. On the other hand, we also have g is approximately 9.81 meters per second squared. This now is the acceleration due to gravity. So these are constants that you would often see in science, probably in physics, but on math, these are known as constants in algebra. Aside from that, we also have what we call the coefficient. So the coefficient refers to a numerical constant. I mean numerical, or a number, or a constant quantity beside a variable. So as an example, we have 2x raised to 4. So in this case, 2 is the coefficient, since x is a variable. This one is not a coefficient, since this one is a exponent. So 2 is the exponent for this one. We also have a and y squared, where a is equal to 1 times 10 raised to negative 9. So although in this example it looks like there are two variables, the a is actually the coefficient, since a is a constant, or it has a fixed value. So constants can also be known as the coefficient. So let's write that out here. So that is the coefficient for this one. For a last example in this one, we have x squared, y squared, and z squared. Now for this one, how do we determine what the coefficient in this one is? Well, the problem here is that x, y, and z are all variables. So neither of them can be the coefficient in this one. But note that we can also write this one as 1 x squared, y squared, z squared. Since 1 is like an identity, since 1 times this whole would simply be the same. So for this one, our coefficient is actually this one. So even though it is hidden at first, we know that when it's not present, when there is no coefficient, it must be 1. So that's it for coefficients. Now let's have algebraic terms. So algebraic terms are a product of numbers, constants, and variables. So for example, we have 5x. So this is an algebraic term since it's a product of a number and a variable. We can also have 3x squared y cubed. For this one, there is a number out here and 2 variables. Lastly, we also have AB over 4C. Now for this one, you might argue that we are using division instead of multiplication. So this does not seem a product of variables and numbers. But take note that even though we use division out here, this is still treated as multiplication since divisions are like multiplying the reciprocal. So we can actually write this one as 4 raised to negative 1 a, b, and c raised to negative 1. Now this one is already a product of variables and numbers. So these are our algebraic terms. Now aside from algebraic terms, we also have the algebraic expressions. So algebraic expressions are basically algebraic terms that are combined through operations. So for example, we have 5x plus 3x squared y cubed. So this first one is an term. This next one is also an term. Since we combine it through an operation, this whole now is an algebraic expression. We also have this example. A minus 3 times b minus 1. So for this one, this first is our term 1. This second is our term 2. And although there isn't an operation, we can assume that there is a multiplication operation out here. And this one is our operation for this one. But note that we don't really need to put this one and as you would observe in future examples, especially in multiplying polynomials, there isn't really an operation put out here. It is already assumed that when there is two parentheses beside each other, that is already treated as multiplication. So again, these are the examples for algebraic expression. Now with all that out of the way, we can now define what polynomials are. So polynomials are algebraic expression with non-negative exponent. So our example a while ago was 5x plus 3x squared y cubed. This one is considered to be a polynomial since the exponents are all non-negative. Indeed, 2 is non-negative, 3 is non-negative, and this one, even though it's not written, by the idea of identity exponent, this one is x raised to 1. So all of these are non-negative. Now let's provide more examples of polynomials. So we have 4x. Again, this is a polynomial since its exponent of the variable is non-negative. We also have 2x squared plus 4y cubed. Now for this one is also a polynomial since its exponent are both non-negative. Now what if we have 5? Now this one can still be considered a polynomial even though it doesn't have a variable. We can assume that if it does, then it's probably just x raised to 0, since we know that x raised to 0 is equal to 1. So it will still be the same. But observe here that the exponent, even though it's 0, it's still non-negative. So we can still consider this one as a polynomial. Lastly, we have this one as an example. We have 3x squared plus 4x plus 5z squared. So again, this one is a polynomial since their exponents are all non-negative. And just take note that this one with one term is actually called a monomial. And so is this one. This one with two terms is called a binomial. And this one with three terms is called trinomial. So take note of these. Lastly, let us show some examples of not polynomials. So we have 3x raised to negative 2 plus 3. Clearly, this one is not a polynomial since its exponent is negative. Also, we have 5y cubed plus 4a raised to 1/2. This one is also not a polynomial since its exponent is a fraction. So both of these are not non-negative integers. So since this one is negative and this one is not even a fraction. And so that's basically it. So take note of the terms that we have presented here, and just having a good grasp of this would help you in real exercises on polynomials in the future. And so that is all for this video.